Hello friends, welcome to Engineering Funda family. In this video, I'll be going to explain you 5 very interesting questions based on memory calculation, or you can say memory interfacing with computer. Let us solve all those questions one by one. Let me explain you first question over here. So here in first question, if there are 512G number of locations in memory, then find number of bits required to represent each location. So how many locations are given over here? 512G. So 512G means what? 512 is 2 to the power 9 and G means 2 to the power 30. See, whenever you have been given locations in terms of K, then you'll have to write 2 to the power 10. When it is there in terms of M means mega, then you'll have to write 2 to the power 20. For G, it will be 2 to the power 30. And for T means tera, you will be having locations as per 2 to the power 40. So here 2 to the power 39 number of locations are there. Why I am converting this in terms of 2 to the power data? The reason is 2 to the power n will define number of bits required to represent each location. So here n is 39. What it means? Number of locations that will be, they are based on 39 bits, right? So as if you have 39 bits, then in total you can represent 2 to the power 39 number of locations, means 512G locations. Let us have second question. So in second question, if you observe, if there are 26 bits available to represent each word of memory, then how many locations can be addressed uniquely? So here how many bits are available? 26 bits. So based on that, we can identify number of locations. Number of locations means number of addresses. So number of addresses based on number of bits, you can say it is 2 to the power n, means 2 to the power 26. But answer will not be given in form of 2 to the power 26, something like that. It will be given based on kilo, mega, giga, right? So here you can say 2 to the power 6 into 2 to the power 20, that is 2 to the power 26. 2 to the power 6 is 64 and 2 to the power 20, that is mega. So how many locations are there? 64 mega number of addresses which can locate data uniquely. Let us have third question. So in third question, if memory is byte addressable and size of memory is 512 KB, then calculate number of bits required to represent each word. So here you see it is given memory is byte addressable. Byte addressable means what? With each word you have 1 byte data, right? Means with each address you have 1 byte data. And here size of memory is 512 KB. Here also you need to understand what is the meaning of this. 512K, that explains number of address. And this B explains how much data is there with single address. So here we are dealing with to identify how many number of bits are required to represent each word. So number of bits, that is based on number of locations. So first of all we need to identify how many locations are there. Number of locations means number of addresses. So number of locations, that is size of memory divided by size of each location. Here what is the size of memory? 512 KB. And what is the size of each location? You see it is byte addressable. So size of each location is 1 byte, right? Means I can say B. So here this B and this B will get cancelled and you will be having 512K number of locations. So that is how we can identify number of locations. But here question is calculate number of bits required to represent each word. When you want to calculate number of bits, then you will have to identify this number of locations in form of 2 to the power n, right? So 512 means 2 to the power 9, K means 2 to the power 10. So in total 2 to the power 19 locations are there. So how many bits are required to represent each location? 19 bits. So that is how we can identify number of bits required to represent each location, right? Let us have fourth question. If you see in fourth question, if the size of memory is given, that is 512 GB. So total size of memory that is given 512 GB. Size of word is 16 bits. Now here we are having size of word that is 16 bits. Find the number of bits required to represent each word uniquely. So here we are dealing with to identify how many bits required to represent each word. So first of all, we need to identify how many locations are there, right? So let us find first how many locations are there. Locations means number of addresses, right? So number of locations, that is size of memory divided by size of location. Size of memory, that is 512 GB. Let me write that 512 GB divided by size of each location means size of word, that is 16 bits. So divide by 16, that we need to do. This B means 8 and this 16 that will get divided by 8. So you will be having 2 over here. This 2 and this 512 that will get cancelled and that will make it to 256. So how many locations will be there? 256G. Now to identify number of bits, we need to have this in form of 2 to the power data. So 256 means 2 to the power 8, G means 2 to the power 30. So in total 2 to the power 38 locations will be there. So how many bits are there to represent each location? 38 bits. So that is how we can identify number of bits required to represent each word uniquely. Also find number of locations required to represent each bit uniquely. See, previously we were been calculating that locations for size of word with 16 bits. But now question is number of locations required to represent each bit uniquely. So memory is same, but now size of word, that is bit only, right? So number of locations will be size of memory divided by size of location. So here size of memory is 512 GB and size of location, that is 1 bit only, right? Each bit means 1 bit. So here divide by 1 that I need to have. Now I need to convert this in form of 2 to the power data. So 512 means 2 to the power 9, G means 2 to the power 30, B means byte, byte means 2 to the power 3. So in total 2 to the power 9 plus 30 plus 3 means 42. So how many bits are required to represent each bit uniquely? 42, right? So that is how we can identify number of bits required to represent each location. Let us have next question, that is fifth question. Now in fifth question, if memory size is 64 GB and if word size is 32 bits, then we are dealing with to find memory capacity in terms of words, in terms of bytes, as well as in terms of bits, right? Also find the number of bits required to represent each word, each byte and each bits, right? So here when you want to calculate number of locations for words, then that will be, locations means addresses. It will be size of the memory divided by size of the word. So what is the size of memory over here? 64 GB divided by size of word is 32 bits, right? So here 64 into G means 2 to the power 30 into B means byte means 8 divided by 32 is there. So this 32, this 64 will make it to 2 and 8 into 2 that will be 16. So you can say here you have 2 into 8 means 2 to the power 4 into 2 to the power 30 means 2 to the power 34. So here you can say number of locations that will be 2 to the power 34. You can represent that in this way also, 2 to the power 4 into 2 to the power 30 means 16G, right? So 16G locations will be there. And as if you want to represent this location in terms of bits, then you see here 2 to the power 34 is there. What it means? 34 number of bits are required to represent each location for word. So n word, that will be 34 bits over here. Now as if you want to calculate same thing for byte, then number of locations, that will be addresses, and here we are calculating this for bytes, right? Here we have calculated that for word. So here I am writing B and here I am writing word W. So that is having same formula, size of memory divided by size of word. Size of memory is 64 GB, and here for byte size of word is 8 bits. So this byte and this 8 will get cancelled. 64G, that will be number of locations, and to represent that in terms of number of bits, you will have to write 64 means 2 to the power 6 into G means 2 to the power 30 means 2 to the power 36 will be there. So here this 36 will indicate how many bits are required? 36 bits required. So to represent byte addressable memory, 36 bits are required. To represent 32 bits of word addressable memory, 34 bits are required. Now, when you want to calculate number of locations for bits, then similarly we can have that as per size of the memory divided by size of the word. Size of the memory is 64 GB. Size of the word is 1 bit. So here you have 64 into G means 2 to the power 30 into B means byte, it means 2 to the power 3. So here we will be having 64 means 2 to the power 6 into 2 to the power 30 into 2 to the power 3 means in total 2 to the power 39. So you will be having 2 to the power 39 number of locations, right? And you can also represent this in form of 2 to the power 9 into 2 to the power 30 means 512G, right? And based on 2 to the power 39, you can say number of bits required will be 39 bits. So when you address 64 GB memory in form of word with size of word of 32 bits, at a time you need to have 34 bits of address lines, right? And data line will be having size of 32 bits. When you want to represent this memory of 64 GB in form of byte, at a time 36 bits required to represent that address, and as per byte addressable, data lines will be 8. And in terms of bits, data line will be 1 only, but address lines will be 39 bits. So that is how we can identify size of memory with varieties of form. So you should understand one thing, based on computer we need to understand what is the size of word. You can have memory as per byte addressable, you can have memory as per bit addressable, you can have memory as per 16 bits of data, right? You can have word size with 32 bits. So based on that you need to calculate all those things. I have seen this type of questions are frequently coming in GATE examination, so you should be doing practice about those things. I hope it is clear to you. Still, if anything that you would like to share, place it in comment box. I'll be happy to help you. Thank you so much for watching this video.